Welcome back to another metrology and measurements session. Today we are going to discuss about the second unit, measurement of linear angular dimensions, assembly and transmission elements. My name is P.NAVIN JASS, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today we are going to see another topic as gear measurement. Gear measurement. Okay, in this gear measurement, we are going to discuss about various topics. Now, first we are going to discuss about what is maybe gear measurement and what is the use of gear measurement. Okay, here, first we should know about what is the use of gears. Gears are mechanical drives which transmit power through the tooth wheel. Here, with the help of the gear tooth, gears are working as a mechanical drives and transmit the power with the help of the gear tooth. The driving wheel is in direct contact with the driven wheel. Okay, here one gear wheel, which we call it as a driving wheel gear tooth, is having a direct contact with the driven gear tooth. Here the accuracy of gearing is very important factor when gears are manufactured. The transmission efficiency is almost 99% for gears. So it is very important to test and measure gears precisely. It is very important to concentrate on the raw materials which are used to manufacture the gears. While we manufacturing the gears, we need to give more importance to the raw materials which is used to manufacture the gear. Then, and also very important to check the machining of the blanks, heat treatment, finishing of the teeth. When we manufacturing the gear, we need to check the machining of the blanks in the gear, and when we giving the heat treatment to the gear and finishing of gear tooth, we need to give more importance to check the machining. Then the gear blanks should be tested for dimensional accuracy and tooth thickness for the forms of gears. Commonly used form of gear teeth are involute gear tooth and cycloidal gear tooth. Here in involute gears, it is also called as a straight tooth gears or spur gear. Involute gears are normally called as a straight tooth gears or spur gear. Cycloidal gears are used in heavy and impact loads. Normally, the cycloidal tooth gears are used when the load is higher than usual and the higher impact loads. We are using cycloidal gears. And then next one is involute rack has straight teeth. Involute rack has straight teeth and involute pressure angle is either 20 degree or 14.5 degree. Okay, so this is the commonly used form of gear tooth. One is involute teeth and another one is cycloidal teeth. Okay, next topic is types of gears. Already we have a clear knowledge about the gears. We got the knowledge about the gears from the manufacturing technology and kinematics of machinery and various subjects we studied about these gears. Okay, normal types of gears are spur gear, spiral gear, then bevel gear, helical gear, worm wheel, and rack and pinion gears. Okay, first we are going to see about spur gear. Cylindrical gears whose tooth traces straight and parallel to the axis of the wheel. Okay, this is the gear that we are showing as a spur gear. These gears are used for transmitting between the parallel and shaft. So the cylindrical gears whose tooth traces is in straight line and it is used for transmitting the between parallel shafts. So this is spur gear, and next one is spiral gear. What is meant by spiral gear? Okay, here the tooth of the gear traces in the form of curved lines. The next one is helical gears. These gears are used to transmit power between parallel shafts as well as non-parallel and non-intersecting shafts. It is a cylindrical gear whose tooth traces in straight line. So this is the helical gears. These gears are the simple modification of the spur gear. This gear is also looks like a gear, but the difference between these two gears is nothing but its teeth. Okay, so here in this helical gear, the angled teeth engage more gradually than do spur gear teeth. Okay, this angled gear which is in the helical gears, or this angled teeth which is in the helical gears, which is to engage more gradually than spur gear which is engaged between the teeth. Okay, so the next one is bevel gears. The tooth traces are straight line generators of cone. The teeth are cut on the conical surface. The teeth are cut on the conical surface. It is used to connect the shafts at a right angle, which we saw in the diagram. Okay, like this only, it is connected to the shafts as right angles. Bevel gears are formed by cutting teeth along the elements of a frustum of a cone. Okay, so the bevel gears are truncated cone and one of which rolls is over other. These bevel gears are commonly used in differentials in the automotive area. Okay, the next topic is worm and worm wheel. Here, this worm and worm wheel is normally connected to the shafts whose axes are on non-parallel and non-intersecting. This worm gear is a gear which resembles a screw, Okay, so a worm is usually meshed with an ordinary looked disc shaped gear which is called worm gear and worm wheel. So it is used to connect the shafts whose parallel or axis are non-parallel and non-intersecting. Okay, so the last topic in these types of gear is rack and pinion. These rack gears are straight spur gears with infinite radius. These rack gears are straight spur gear with infinite radius. So this rack is a toothed bar or rod that can be thought as a sector gear with an infinitely large radius of curvature. Here, the torque can be converted into a linear force by meshing rack with the pinion. When the pinion turns, the rack will move in a straight line. When the pinion turns, the rack will move in a straight line. Okay, the next one is spur gear terminology. Next one we are going to see is spur gear terminology. So here there are different terminologies are here. One is hole depth, working depth, addendum, dedendum, tooth thickness, clearance, fillet radius, then dedendum circle, clearance circle, bottom land, flank, face, top land, pitch circle, width of the space, addendum circle. Then these are the things are in the spur gear terminology. Already we studied about truth terminology. Now we are going to study about spur gear terminology. So the first one we are going to see is tooth profile. We should know about tooth profile. It is the shape of any side of gear tooth in its cross section. It is a shape of any side of gear in its cross section. So tooth profile is any side of gear tooth in the cross section. Next one is base circle. Next one is base circle. It is a circle of gear from which the involute profile is derived. Base circle diameter which is equal to pitch circle diameter into cosine of pressure angle of gear. Pitch circle diameter into cosine of pressure angle of gear. The next one is pitch circle diameter. Pitch circle diameter. It is the diameter of circle which will produce the same motion as the tooth gear wheel. It is the diameter of circle which will produce the same motion as the tooth gear wheel. So next one is pitch circle. Next one is pitch circle. So what is from a pitch circle? It is the imaginary circle of gear that rolls without slipping over the circle of its mating gears. Okay. So pitch circle is nothing but is the imaginary circle of gear that rolls without slipping over the circle of its mating gears. Then next one, addendum circle, dedendum circle. Addendum circle, dedendum circle. So this is the addendum circle and this is the dedendum circle. Here in addendum circle is also called as a tip circle. Addendum circle is also called as a tip circle. Okay. So it is the circle coinciding with the crest or top of the tooth. It is the circle coinciding with the crest or top of the tooth. Okay. Then dedendum circle, it is also called as a root circle. It is also called as a root circle. So here the circle that coincide with the root, the circle that coincide with the root of the gear tooth or bottom of the gear tooth, then it is called as a dedendum circle. Then it is called as a dedendum circle. Then face of the gear tooth. Next one is face of the gear tooth. It is a part of the tooth in the axial plane existing between tip circle and pitch circle. So this face is placed between the tip circle, which is called as a addendum circle, and pitch circle. This face is placed between the addendum circle and pitch circle. Next one is flank. Next one is flank. This flank is placed between pitch circle and root circle or dedendum circle. Okay. So this flank is placed between pitch circle and dedendum circle or root circle. Then next one, top plant. Next one is top plant. The top surface of the tooth is called as the top plant. The top surface of the tooth is called as the top plant. Then pressure angle alpha. It is the angle made by the line of action with the common tangent to the pitch circles of mating gears. Okay. So if pressure angle is nothing but is the angle between or made by the line of action with the common tangent to the pitch circles of mating gears. So mating gears tooths or mating them to the pitch circle. So when the angle clears or shows that is called as the pressure angle. Okay. Now the next one is module. It is the ratio of pitch circle diameter to the total number of teeth. So M is equal to D by N, and D is nothing but pitch circle diameter and N is the number of teeth in the gear. So module is nothing but it is the ratio of pitch circle diameter to the total number of teeth. So ratio is nothing but M is equal to module M is equal to D by N. The D is nothing but pitch circle diameter and N is equal to number of teeth. Okay. So the next one is circular pitch, which we call it as a PC. Circular pitch, which we call it as a PC. So it is the distance along the pitch circle between corresponding points of adjacent teeth. So it is the distance along the pitch circle between the corresponding points of the adjacent teeth. So PC is equal to pi dn, which is equal to pi into m. So why we take it as a pi m? M is equal to d by n. Okay, so m is equal to d by n. Here the formula is PC equal to pi dn. So here pi into d by n is formed as module m. Now the next one is diametral pitch. Diametral pitch. So diametral pitch is nothing but PD. So number of teeth per inch of the PCD. Number of teeth per inch of the PCD. So here PD is equal to N by D, which is equal to 1 by M. So D by N is equal to M. Here we are taking N by D. So inverse of the module M. So here we are taking, instead of N by D, we are taking 1 by M. So PD is equal to 1 by M, where M is nothing but it is a module. Then the next one is addendum, dedendum. Next one is addendum, dedendum. Addendum is nothing but it is the radial distance between the tip circle and the pitch circle. Tip circle and the pitch circle. So that is called as addendum. So addendum is equal to one module. Addendum is equal to one module. So addendum is equal to 1 into m. Now dedendum. So dedendum is nothing but it is the distance between or radial distance between pitch circle and the root circle. It is the radial distance between pitch circle and the root circle is called as dedendum. So dedendum is equal to 1.25 into m or 1.25 module. Then next one is clearance. This is called as clearance. This smallest gap is called as clearance. So the distance covered by the tip of one gear with the root of a mating gear, that is called as clearance. The distance covered by the tip of one gear with the root of a mating gear is called as clearance. So clearance is equal to difference between dedendum and addendum. Difference between dedendum and addendum is called as clearance. Next one is blank diameter. Next one is blank diameter. It is the diameter of blank up to outer periphery. It is the diameter of blank up to the outer periphery. Blank diameter is equal to pitch circle diameter PCD plus 2 into module. Pitch circle diameter PCD plus 2 into module. That is called as blank diameter. Then next one is helix angle. Next one is helix angle. A helix angle is an angle between any helix and axial line on its right circular cylinder or a cone. The typical range of a helix angle is about 15 degree to 30 degree. Likewise, lead angle is nothing but it is the angle between tangent to the helix and plane perpendicular to the axis of a cylinder is known as lead angle. The next one is backlash. Last topic in this spur gear terminology is backlash. So it is the difference between the tooth thickness and the space into which it measures. If we assume tooth thickness as T1 and width is T2, then backlash is nothing but T2 minus T1. Backlash is an amount of tooth space between mating gears at the pitch circle diameter, and it is a distance through which a gear can be rotated to bring its non-working flank in contact with the teeth of mating gears. Backlash in gears is the play or clearance between mating teeth. The greater accuracy, the smaller backlash is. So here backlash is nothing but the difference between the tooth thickness T1 and width T2. Tooth thickness T1 and the width T2 is known as backlash. So backlash is equal to T2 minus T1. Now the next one is errors. What are the errors occurs in the gear? So many errors are there. Here profile error, pitch error, cyclic error, run out error, eccentricity, wobble, radial run out, undulation, then periodic error, axial run out. So these are the some of the gear errors. Okay, the first one is profile error. It is the maximum distance at any point on the tooth profile form to the design profile. So in the tooth profile form to the design profile, when in the gear, when we sing this spur gear terminology, this gear has the maximum distance in the tooth. So in this maximum distance tooth, the profile form to the design profile, some errors may occur between the mating gears. So that is also one of the error called as profile error. Okay. The next one is pitch error. It is the difference between actual pitch and the design pitch. Okay. The pitch error is nothing but the difference between the actual pitch which is in the gear and the design pitch that is in the design. So there is some minute errors may occur in the pitch error. Then next one is cyclic error. It is the error occur in each revolution of the gear. So This cyclic error, when the gear rotates with its mating gear, one revolution or one cyclic rotation is completed, we may found out some error. That error is called as cyclic error. The next one is run out error or radial run out error. It is the maximum perpendicular distance variation of the gear surface when rotated without axial movement about the gear axis. Run out of a gear can be measured with a dial indicator. These types of run out measurement can be, or run out error can be identified, or how much amount of error may occur. Uh, we can able to identify with the help of the dial indicators. Then next one is eccentricity. It is a half radial run out. When the gear rotates, the half radial run out of the gear may occur. So eccentricity occurs when the center of the rotation is offset from the geometric center line of the gear. So when the geometric center, the gear is move away from the rotation that we fixed in the geometric center line of the gear, that is called as eccentricity. The next one is wobble. It is also called as a axial runout. This wobble runout measure is parallel to the axis of rotation at a specified distance from the axis. So that is called as wobble. And undulation. Undulation is nothing but it is a periodical departure of the actual tool surface from the design surface. So that's the variation between the actual tool surface and the design tool surface is called as undulation. The next one is axial runout. That's we already studied about in the wobble. And next one is periodic error. It is the error which occurs at regular intervals. This periodic error which occurs at the regular intervals or a regular period time. It may occurs in the certain period time, that is called as periodic error. So by this session is over. We are going to study the more topics in the upcoming sessions. Thank you.